In all the previous lessons, we've talked about things that are really, some of them were C++ specific, but really nothing you couldn't do in C. And the big advantage to C++ was that we could write classes and we could do true object-oriented programming. So let's write our first class. And first we'll just go through some of the steps for just using Eclipse to do it. So you right-click on your project. I just created a hello world and called it units class. And you can say new, and you can say class, and drag this down, and you give your class a name. And we're going to write a class that just takes time and makes it a little simpler for us. It'll take a value, and then we'll be able to ask this class to give us the time value in microseconds, milliseconds, nanoseconds. So let's just call it time, and you can see it does a header and a CPP file for us, and I've got constructor, so it's automatically going to create a constructor, which is something unique to classes. And then let's say finish and let it do it. So I think at the simplest concept, classes are nice ways to put together your data and the methods that act on that data, and kind of hide things from other parts of your program. So it's really a maintenance tool and a simplification tool. So we haven't talked a whole lot about scope, but typically over here in our main, any variables we declare inside main, those are local variables, and main can see them. If we put them up above, they become global variables that the whole program can see. The nice thing about classes is you can have a public and a private section, and any data in the private section can only be seen by this class. Okay, so we're going to create a double. We're going to call it the time in, by default, we'll just store everything in nanoseconds. Okay, so only our class knows about this and uses it. Okay, so and then the class is called time, and you see it automatically created this function called time, this method called time with no return value. That's the unique signature for a constructor. Has the same name as the class, has no type, and then takes parameters. And we're going to want to, when we create a time class, we're going to want it to have a value. So we're going to pass in a double. And what Eclipse did for us was it, over here in the CPP, it automatically put in the scaffolding for us of a class. Everything, when you're in the CPP, you always need to specify what class, even though you think the compiler might figure it out because they're named the same. Just pretend it doesn't, that it's dumber than that. So it always wants to have the class name first for everything you do here. Okay, and then one other new piece of syntax that it belongs to classes is something called the initializer list. And I guess I should point out, you could, so that member variable that we had, and I used a naming convention of m, just because I type ahead works, but I have to hit save here for that to work. So that's just a convention. You don't have to name them with a leading M and an underscore like that. It's just something I like to do, and it's a fairly common convention. So you could say, remember we changed our signature here to take a value, so we have to do that in the CPP as well. So we could say value. But what C++ does is it automatically initializes classes and strings and primitives to default values. Well, I'm not sure about primitives, but classes and strings to default values before you get into the body of your constructor. So sometimes things will end up getting initialized twice. So it's a good habit to get into to use what's called the initializer list. So in your constructor, you hit a colon, and then you put in any variable you want to initialize, any member of your class you want to initialize, then parentheses, and the value that you want it to have. In this case, its value. And then if there's more than one, you separate them with commas and you put them in there. Okay, so that does the same thing as this, so we no longer need this here. Okay, so that part right there, that's called the initializer list, and that's kind of how you want to get used to, and it doesn't have to be on the same line. This can go anywhere. C++ doesn't care too much about white space. So if I have just a couple, I usually just string them together. If I have a whole bunch, I sometimes put them with a comma, and I put them all on separate lines. Okay, so that initializes our class. So so now we need some functions that are public. So we want to be able to see, we want to get back the time in nanoseconds, which is how we're going to initially set it. We want to get the time back in microseconds, and we want to get the time back in milliseconds, and we want to get the time back in, say, seconds. Okay, so normally, and I'm going to hard code some constants. Normally I would put them down here in my class, but just to keep this example simple, let's just come over here. And okay, so the first thing we do is the return type, just like any other time we're defining a function. Then the class that we're going to put this in, time, and then we called it nanoseconds, and capitalization matters, and I hate the fact that I always have to remember to save before my type ahead works. Okay, so there's nanoseconds. Doesn't take any parameters, and what we're going to do is we're just going to return the time in nanoseconds, because remember, this is private, so that nobody can ask for this directly from outside our class. They can't see this. So if we want them to know the time in nanoseconds, we have to have, basically this is called a getter. And sometimes I should point out, you'll see these written in the .h file as well. When they're real simple, the compiler tries to inline. If you put it here, it'll automatically inline the code. But it's not specific to classes. So then now we can say we want this in microseconds. You see how we don't have to pass anything around, right? Because everything can get direct access to our member variables. Okay, so now we take our time in nanoseconds and we divide it by 1,000, right? And we'll have our time. And this is what I would normally never do, but I'm just keeping the example simple for now. And if we have time, we'll go back and we'll make these all static named constants in our class. Okay. And I'll just write the rest of these. Okay, so there's my microseconds, milliseconds, and my seconds, and they're the same one, so everything is satisfied. So this should now compile. Okay, so it looks like it did. So now let's go back over. Now we have a little class, has one piece of data that gets shared among these functions. So we can come back over here to main, and we can instantiate an object of that class. So I guess these terms you have to get used to a little bit. But so this is a class, and you know, it's sort of a template of the things that it's a contract. It shows the public part shows what functions it has. The users of this class don't care about any of its private data. Okay, but the way we use it is we, just like any other variable name, well, first we need to include it so that it sees it. So let's say include time.h. Okay, and then down here I can create an instance of my time by specifying the class name and giving the variable a name. Okay, and then it takes a parameter, so I need to specify the parameter. So in this case, let's just give it 1 billion, which should be 1 second. And now my time is an instance of time. And the only other thing I want to point out right up front is if I had a class, if it didn't take any parameters, this trips up people a lot. You would declare it like that. You would not declare it like this. Okay, because it's a sort of a different syntax in C++. C++ is seeing this as something as my time is a function that returns time. So the only thing to remember is when you have no parameters, you just don't put the parentheses. You just do that. When you do have parameters, you put the parentheses and the parameters you need. Okay, so there we have an instance of my time, and then any public functions or data, which is generally a bad idea to make public data, but you put a dot, and then you can, okay, you can see it show up here, but it won't let you use that. That's what that red square kind of indicates, is that it's private. You know, we put it here, but this wouldn't compile. It's going to tell us, you can actually see the code and error over here, saying it's not visible, so because it's private, so you can only get to the visible things. So if we want to get to this in nanoseconds, it's gonna, you know, that's gonna print out. Let's just see out these, I guess. So this is gonna print out the billion, and then I'll pause this and I'll write them all. Okay, so there I'm calling the nanoseconds, the microseconds, the milliseconds, and the seconds. Let's go ahead and build that, and then let's hit run. And then you can see there's 1 e to the ninth, so there's a billion, there's a million, there's 1,000 for the milliseconds, and there's 1 second in that time. So you can probably see how this is useful. And this is just scratching the surface of classes. They do a lot more, and there's a lot more new syntax, but I thought this would be a good introduction to just seeing how you can kind of marry the data and some functions in a single unit, and work with them. And often you'll see the need for classes when you're passing around a lot of data. That's kind of an indication that maybe that group of functions and that group of data all needs to get packaged up together in a class. Classes don't have to be these huge big things. They can be little small things like this that perform single functions and save you time and maintenance. So instead of always doing those divisions that we do here all over your code, every time you need milliseconds or microseconds, you bury them here. And like I said, having these hard-coded constants here isn't a good idea, and maybe we'll look at that again. But I think that's enough for an introduction to classes.